Hello everyone, welcome back to my YouTube channel. This is Sahana LK from the fourth sem stages section. Today I'm here to discuss about the subject of control system. In that I chosen a topic of translational mechanical system. Here, translational mechanical systems moves along a straight line. These systems mainly consist of three basic elements. Those are mass, spring and dashboard or a damper. Let us discuss about the mass. Mass is the property of a body which stores kinetic energy. If a force is applied on a body having a mass m, then it is opposed by an opposing force due to mass. We can see here the diagram. Here it is having a mass. It is applied opposite to the force. Here we are having some equations. Fm equals to ma. Nothing but a is the acceleration. We can define that as m d square x divided by dt square. Here Fm is nothing but same. Here F is the applied force. Fm is the opposing force due to mass. M is the mass. A is the acceleration and x is called a displacement. Let us discuss about the spring. Spring is an element which stores potential energy. If a force is applied on a spring K, then it is opposed by a opposing force due to elastic of spring. We can see here. Here we having a spring which is having the force which is applied through the spring. Here F is directly proportional to the here X is directly proportional to the displacement X. Here, proportional is replaced by the K. K is called as a proportional constant. Here, F is the applied force. Fk is the opposing force due to elastic of spring. K is the spring constant and X is the displacement. Dashport. It is a force is applied on a dashport B. Then it is opposed by the opposing force due to the friction of the dashport. This opposing force is proportional to the velocity of the body. We can see in this diagram. Here we are having a dashport is denoted by the letter B. Here we are having a displacement and we are having a opposing force which is proportional to the velocity of the body. Here dashport is directly proportional to the v is nothing but velocity. Here proportionality is replaced by the constant called v. We can see here the equation for the dashport b into dx by dt. Here Fb is the opposing force due to the friction of dashport and v is the friction coefficient and v is the velocity and x is the displacement. Here, electrical elements and mechanical elements are two physically different systems. These are two types of electrical analogues of translational mechanical systems. Those are force, voltage analogy and the force current analogy is nothing but FE analogy and the FI analogy. Here, let us discuss about the force voltage analogy. In the force voltage analogy, the mathematical equations of translational mechanical systems are compared with the mesh equations of the electrical systems. Here, in translational mechanical system, we are having the force F, mass M, frictional coefficient B is nothing but the dashport, and spring constant K, displacement X, velocity V. In By replacing the translational mechanical system by the electrical system, where force is replaced by the voltage, mass is replaced by the inductor L, frictional coefficient V is replaced by the resistance R, and the spring constant K is replaced by the reciprocal of capacitance is nothing but 1 by C. Here displacement X is replaced by the charge Q, velocity V is replaced by the current I. Next, force current analogy. In force current analogy, the mathematical equations of the translational mechanical system are compared with the nodal equations of the electrical system. Before we are using the mesh analysis, here we are using the node analysis. In translational mechanical system, we are having the same kind of components like force, mass, frictional coefficient, spring constant, displacement and velocity. In this force current analogy, the electrical elements are replaced by the translational mechanical system. Let us see. Force is replaced by the current. Mass is replaced by the capacitance C. Frictional coefficient is replaced by the reciprocal of the resistance, that is the 1 by R. Spring constant is replaced by the reciprocal of inductor, is nothing but 1 by L. Displacement X is replaced by the magnetic flux, that is phi. Velocity V is replaced by the velocity, is nothing but V. Small letter V we are using. Let us discuss an example based on the concept. Here, find the transfer function x of s divided by f of s for the system given below. We are having a diagram which is, in this, mass m is attached to the spring constant as well as dashport. It is having certain some displacement and it is also having some applied force. In this concept, we are going to the first step. Firstly, we will draw the free body diagram of the mass m. This diagram will replace it by the free body diagram, is nothing but separately we are writing for the mass m. We are having the spring constant here K, a dashport is B, and having some displacement and the forces. Here in this diagram we are having mainly spring constant and the dashport, and some acceleration is nothing but mass. These are all having some replacement. We will replace those elements by in terms of electrical elements. Here K into x of t and B into dx of t divided by dt. Mass is replaced by m into d square x of t divided by dt square. Here we are having a free body diagram. In this, mass is attached to some electrical components called spring constant, dashport, as well as some mass. Here, next step is sum of all the forces acting on a body is equal to the 0. Based on this statement, we will write the which are all having a electrical components. F of t, which is force applied on the mass. Next, K into F of t, B into dx by dt, M into d square x of t divided by dt square equals to 0. For this equation, we should apply the Laplace transformer. Then the equation will be replaced by, here f of t is replaced by the f of s when we apply the Laplace transformer. Here same k into x of t is replaced by the k into x of s. Same dx by dt is replaced by the s into x of s. Then here d square x of t divided by dt square is also replaced by the s square x of s. In these all terms, we are having a common term called x of s. So we are taking the common term as a x of s. Then k will be leave as it is. Here b into s, here m into s square. If we take this x of s to the left hand side, then it will become x of s divided by f of s. Here this term will become the reciprocal. So we are having the final. So at last we are getting the equation which is x of s divided by f of s, which is equals to 1 divided by k plus b into s plus m square s. This is what the required equation at last we got. Thank you for the listening.